Hello, everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to Technical Session 6F. My name is Anisha, and this session would be moderated by me on behalf of Global Knowledge Research Foundation and GR Scholastic LLP. It is my great pleasure to welcome you all to the 4th World Conference on Information Systems for Business Management, ISBM 2025, Bangkok, Thailand. The 4th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 25th and 26th of September 2025. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I'll be raising a gentle reminder. There's another request to all the participants to please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So before we start with the session, I'd like to introduce you all to the chairs for this session. Dr. Anne Julie D. Rosal. He's a dedicated academic leader and researcher at Pangasinan State University. He currently serves as the head of sustainable development and futures thinking, leading the university's initiatives to align program and projects with the United Nations Sustainable Development Goals. With strong research interest in business administration and information technology, he focuses on the integration of technological advancement with business strategies. We welcome you to the session, sir.
Yes, ma'am, thank you. So it is my pleasure to join you to this session where we gather to celebrate the power of research, inquiry, and shared learning. So to all presenters, thank you for being here and for the dedication behind your work.
Thank you for your words, sir. And we have another session chair, Dr. Kaushal Shah. Dr. Kaushal Shah is an assistant professor in the Department of Computer Science and Engineering at Pandit Deendayal Energy University with around 11 years of teaching experience. He has published several research articles in reputed venues and has delivered keynote talks. His areas of interest include blockchain technology, information security, data structures, and smart grid. We welcome you to the session, sir.
Yeah, thank you for having me. All the best to all the participants and be precise, right? Be precise, be on time. I'm sorry, I'll have to take this call.
Okay. So moving forward, we have the very first presenter, Prem Chand, with the paper titled ECG, Go Device, a low-cost multifunctional wearable for integrated real-time cardiac and mobility monitoring. So you may start with the presentation.
Yeah, ma'am, can you please confirm me? Am I audible to all?
Yes, you are audible. So
Yeah.
are you the co-author of the paper and you will be presenting on his behalf?
Yeah, I am co-author and he's Prem Chand. So we are both here.
Okay.
Yeah.
Okay, you can go ahead with the paper.
Can you please confirm? Is it visible to all of you? We have shared our screen. Is it visible? Yeah, thank you. So a very good afternoon to all of you present here. Welcome to our presentation. We are from Indian Institute of Technology, Mandi, and Indian Institute of Technology, Bombay. So this is a collaborative work where we have explored and low-cost ECG device. We have named the work as ECG Go device, a low-cost multifunctional wearable for integrated real-time cardiac and mobility monitoring system. The problem statement is nowadays the whole world is facing this cardiovascular disease problem, which goes to leading a global mortality. According to the data, 17.9 billion annually, it is affected by this problem. The long-term monitoring system is essential for this, but due to this hospital-based system are very costly, and these are for long time or long period of monitoring. These are impractical process. With the problem, these are very high cost, very single function and proprietary software and lack of contextual monitoring system. We have worked on this area. the research gap we have taken here. We have developed a low-cost ECG system, and the quality of the signal we have met. Previously, the literature have faced the problem with poor signal quality, limited HRV parameter, and also this mobility problem, the fall on step detection for the elderly patient or the people. Our approach of the solution, we have introduced this ECG Go device with low-cost, portable, and multifunctional wearable device. We have worked on its affordability. We have worked up to $48 of the device, which makes it a very 10% up to a low-cost device, a clinical reliability with high-quality ECG and HRV measures, multifunctionality. It is having with ECG, HRV, and fall detection, and also the step counting. It is very user-friendly and integration with this mobile data and mobile application. The alert are integrated with the BLE sensors and the mobile application and the cloud. The safety measure we have taken here for the elderly patient. The key innovation combine this all 3 or 4 measures into this cardiac monitoring and mobility system. We have used MAX 3003 AFE plus RP 2040 plus ICM 20948 IMU sensor for this accuracy and for the ECG data connectivity. Yeah. So our system architecture is comprises of this integrated of this hardware, firmware, and the software, that is the mobile app and the cloud, which continuously taking the data and processing it behind on the cloud and making it into the mobile application. So we have used this mobility BLE 5.2 for the communication purpose. We have used this hardware MAX 3003 ECG FE, and for the microcontroller we have used RF 2040, and for the BLE we have taken 5.2, and for the IMU sensor for the mobility and for the step counting we have used ICM 20948. Battery we have used 3.7 volt of LiPo plus USB-C charging type. Please go ahead. Yeah, so if we compare the cost, we have reduced the cost up to $48, where we have also compared this cost with the already market device, that is Simmer 3 ECG unit, which cost around $605 and EMY Pro Plus 538, and our ECG Go device cost around $48. So this is the comparison with respect to the low cost device. Now for the validation of the data and the parameters, we have done a study with 44 healthy adult, age limit from 23.8 and with standard deviation 2.5 years. We have taken 12 time domain HRV measures, including SDNN, RMSSD, NN50, PNN50, and etc. We have used this step count accuracy for 10 days monitoring system, and also we have used this fall detection. So from this 44 healthy participant, we have collected the data. In the same time, we have collected their data from the CMAR, and also we have analyzed this data. We have done statistical analysis to see whether this data is statistically significant. They are making any difference or they are same. So coming to the result, we got not significantly insignificant difference for all the parameter we have taken here. All the P are 0.05, so they are insignificant. So there is also stronger perfect correlation between the Simmer sensor and between the ECG Go device sensor. We can also see in the graphs they are quietly comparable numbers. So there is no any non-significant result we got. Coming to next. Yeah. So coming to the fault detection and step count, we have achieved 96% detection accuracy in a simulated low impact fall, and there is no false alarm during this normal sitting and walking. We have also delivered this message to 1.2 second of the time, which demonstrate a very potential for the ideally safety monitoring system. We have used this step count validation. We have taken ECG Go device and we have taken this Fitbit Sense 2, and during the 10 days study we have calculated the differences between our device and the already market benchmarking device. So we got a strong correlation of 0.94, which is highly consistent with the trend tracking. Coming to the discussion part, we have taken all this HRV data, we have taken this mobility data, fault detection data, and this low cost device is very comparable to SIMAR theory, which is very research grade and in the market. And this is also outperform of the Fitbit this count step data analysis, which is integrating the mobility monitoring system. Also this 96% of fault detection, and also this step tracking of correlation 0.94, which proves the reliability in the real world context. So coming to the conclusion, we have built this low cost device with only $48, which multifunctional, clinically reliable wearable, which combined this ECG, HRV, step count and the fault alert, which makes it very perfect solution for the market and for this research gap. Coming to the future work, if we see there we can integrate blood oxygen monitoring system, stress and fatigue assessment, and also this AI based system which will tell you the different diseases which can occur in the long term monitoring system. So cloud connectivity, clinician dashboard, and this caregiver support we can all integrate in the future work. So thank you, and if there is any question, please. Thank you for listening us.
Session chairs, do we have any questions for them?
Yes, ma'am. To our researchers, given the strong validation results that you had, what possible enhancement or new functionalities are being considered to support predictive analytics or early intervention high-risk populations?
Yeah, sorry. Yeah, please go ahead.
For this, what we are doing in our next version of this device, we are adding a SpO2 sensor, so we can continuously measure those oxygen saturation and other stuff. And then we are implementing some machine learning models. So what we can do, we can collect all the data in our cloud servers, and then we can predict the any diseases the person can get in future.
Thank you.
Yeah, so I mean, you have made that cost analysis, and
Yeah.
reduction of cost, it was around 90%, more than 90%, right? So that's a significant reduction. So that's where I want to know why others are so costlier.
Yeah, so the problem with the market is, one thing we can consider, like they are very they made the software, they are not making the things, the hardware, the software open source. So this is the one reason. Any software we need to install, we need to pay. So there is no open source in the field of this ECG monitoring and everything. So this is one thing. So the companies want their technologies in-house only. They are not open source. So this is one of the reason.
Okay, so if there are other players who would start using open source, then the cost would be comparable with whatever you are claiming, right?
Yes,
Yeah.
sure.
And is
Because
there any terms of, I mean, efficiency reduction if we reduce the cost this much?
No, yeah, that's why we have done this study. Now we have taken 44 participants, and then we have collected the data at the same time with the standard market device and our device. So to benchmark our device data accuracy, so we have taken across all the parameter of the HRV, across the 12 parameter, and we have compared with the standard market device. So that's why this validation comes with an within this low cost device and reliability with this benchmarking with the parameters.
Okay. Okay. Thank you. That's it from my side. All the best.
Thank
Yeah,
you.
thank you.
Thank you for the presentation. Moving on to the next presenter, we have a holistic review of deep learning methods in speech emotion recognition. She couldn't present in the previous session, so we will be taking her presentation here. With the presentation. I guess there is still a network issue. We request you to solve the network issue from your end. Till then, we'll be moving forward to the next presenter for this session. We have Tushar Yenduri with the paper titled A Comprehensive Benchmark for Evaluation Inference Strategies on Large-Scale Tabular Datasets.
Yeah, good morning.
Tushar, are you?
Yeah. Am I audible?
Yes, you're audible. You can start the presentation.
Okay, I'm starting sharing my screen.
Sure.
So is it visible?
Yes, it's visible.
Yeah, okay. So good morning, everyone. Today I will present our work, a comprehensive benchmark for evaluating inference strategies on large-scale tabular data sets. This study was conducted with my co-authors, Hemant Kondori and our mentor, Dr. Kalyan Netty at NGRI, National Geophysical Research Institute, Hyderabad. The heart of this research lies in a practical question. When data grows to millions of rows, how do we ensure machine learning models make predictions quickly and reliably? Think of it like a busy airport, security line. Training is like building the infrastructure once, but inference is like screening every single passenger every day. Efficiency here decides whether the system keeps moving smoothly or collapses under the pressure. The motivation and problem statement for our topic. Machine learning has become the backbone of physics, genomics, and climatology. But as data sets grow, inference becomes the bottleneck. Consider the Higgs dataset, originally over 11 million collision events, each with 28 features. That's like trying to sort billions of packages in a logistic hub every single day. Training is very heavy, but it's one time. Inference, on the other hand, happens continuously in production. Real world systems like CERN detectors or industrial IoT systems need predictions not just accurate but also fast and repeatable. Our work addresses this tension between scale and efficiency. Our objectives were threefold. First, to benchmark three inference strategies: serial execution, multi-core parallelism using joblib, and distributed memory execution using MPI. Second, to compare them systematically on runtime, throughput, speed up, and efficiency using Higgs dataset. And third, to give practitioners a decision framework, like a playbook, on which approach to choose for their scenario. Think of it as comparing three modes of transport. Walking alone is serial, carpooling with friends is jobbling, and organizing a convoy of buses is MPI. Each has trade-offs in speed, coordination, and complexity. Dataset and model. We have used Higgs dataset, which originally contains over 11 million simulated particle collisions with 28 real valued features such as momentum, energy, and angles, etc. For this study, we deliberately used only 30% of the dataset, about 3.3 million rows, so that we could test inference strategies within manageable runtime and resource limits. After pre-processing with Z-score normalization, we trained a random forest with 100 trees, roughly 2,36,000 rows were used for training, while inference was tested on 2.6 million rows. The model achieved 73.3 accuracy and an ROC area under the curve of 81.25%. Think of this data set like monitoring millions of heartbeats in a hospital system. You don't just need the accuracy, you need to handle the volume without delay. Our proposed strategy. We compared three inference approaches. First, serial inference, one thread, simple baseline, no coordination overhead. Second, job-lab parallelism. Data split across 8 logical CPU cores, much like a kitchen licks with several chefs participating dishes independently. Third is distributed MBI, 4 processes running in separate spaces, like multiple restaurants in different parts of the city. Each promises speed, but also brings its own overhead, synchronization, communication, and etc. What were our results? Our findings on 30% of the data sets were counterintuitive. Serial inference completed in 139 seconds with 62,000 rows per second. Overall, fastest overall. Job-lib through parallel took 232 seconds, about 37,000 rows per second. MPI, despite being designed for clusters, was slowest at nearly 585 seconds, just 15,000 rows per second. We have also tried various other models in the similar fashion, but random forest classifier was the best choice for this R data set. As we can see, serial has done the best performance. So why did the simplest strategy win? Serial execution benefits from cache locality, predictable memory access, and no coordination overhead. Joblib was limited by Python's global interpreter lock and shared cache continuation. Like too many people sharing a small fridge. MPI faced the heaviest burden, serialization, inter-process communication, and redundant model loading. Much like different restaurants needing to share ingredients but constantly reordering them. So it made it complexity. This shows that complexities can sometimes backfire at moderate scales. Key observations. The critical insight is that more parallelism is not better performance always. Overhead can erase theoretical gains. Since we tested on 30% of Higgs dataset, the results reflect moderate scale workloads. For datasets below 10 million rows, serial or shared memory approaches are often best. For massive workloads, hundreds of million distributed methods start to shine. This is like choosing between bicycles, cars, and aeroplanes. For short distance, a bike is faster door to door. But for cross country, of course, you need a plane. So the context matters so as to what model we use. Based on our finding using 30% of the data set, we built a simple framework for single node deployments or moderate data sets. Serial inference is the strongest baseline as of now. So to conclude, our study shows that sometimes the simplest solutions outperform the complex ones, especially at moderate scales. We have benchmarked inference strategies side by side and offered a framework for real world deployments. Moving forward, we would want to explore energy efficiency, pre-processing overhead, and accelerators like GPU or model compression. The bigger message is inference infrastructure is not just an afterthought, it's a core performance determinant. Just as a well-designed highway determines traffic flow more than the types of cars, inference strategy often decides whether machine learning works in practice. We would like to thank our research institute, National Geophysical Research Institute, Hyderabad. And special thanks to all our mentors and collaborators. Thank you. And we also have my teammate Hemant here, who will now be answering the questions.
Session chairs, do we have any questions?
Yes, please. Researcher. So, how do the trade-offs between JOD-LIB and MPI affects real-world deployment decisions, especially in a resource-constrained environments or say edge computing scenarios?
So the trade-offs between MPI affect the real-world decisions in a way that this was data which was taken out from the Large Hadron Collider by University of Berkeley and in collaboration with CERN. So this data we have only used 30% of the data. So due to the resources available, so we didn't test the whole data set. So the trade-offs would be when tested for 100% of the data set, there would be the results would be somewhat here and there with plus or minus of the time for each and every serial MPI using JobLib or using parallelism. So that would be the trade-off. It would be near and there when we tested for 100% of the data set.
All right, thank you.
Yeah.
Yeah, no questions from my side. You can go to the next presenter.
Yeah, thank you so much.
Thank you, sir. Thank you so much.
Thank you so much for the presentation. Now we'll be moving forward to the next presenter, and we have Kevin De La Cruz with the paper titled Advanced Planning for Lean, Circular, and Sustainable Decision Making in Textile Manufacturing Company, TOPSIS approach. Do we have Kevin with us in the session?
Hello. Hi. Hi, everyone.
Yeah. Okay.
We shall know. Okay.
Yeah, you can share your screen and start the presentation.
Okay. Thank you. Okay. Good morning, everyone. My name is Kenny Steve. I'm accompanying Alberto Taza. I'm a historian in order to be here preaching or the research. The word is going to share with is and the title Advanced Planning for Lean, Circular, and Sustainability Decision Making in Textile Manufacturing at TOPSIS approach. This actually was carried in a collaboration with college. It's motivated with one of the great challenge that modern manufacturing face today, how to simulate achieves efficiency, competitiveness, and sustainability. Traditional combined team that treat these goals separately first focuses on sufficiency, then later and environment improvements. However, these questions approaches the longer and now industry specials the textile sectors are now required to move to faster balancing all three dimensions of the at the same time. What it will represent is synthesis of the contributions and results we had obtained so far the extensive versions of this work will go deeper into the theoretical discourse, mathematical justifications, and broader empirical validations. But today my purpose is to share the core insights that are the most relevant for decisions making in the textile industry. Okay, the next slide. As far as objective, the textile sector is under unprecedented pressure. On the one hand, there is that economy pressures, company must remain competitive in a global market where cost and delivery times are so critical. On the other hand, there is the environment pressure society and governance are demanding lower emission, less weighted consumptions, and more responsible production process. In the concept, our research proposed an integrated decision-making framework that lean manufacturing, circular economy, and sustainability. To evaluate and prioritize alternatives, we applied the TOPSIS method, a robust multi-criteria decision-making and technique that allow us to compare the different strategies using both operational and environment indicators. The object of our research is twofold. First, offer a practical tool that manager can use to optimize resource, reduce waste, and meeting regulated requirements. So second, the contributed the containment fields be is no way that lean security and sustainability can be analyzed together under a single structured models, or finger sagas that leans practice, especially when combined with circularity, not only generates short-term efficient gains, but also establish a foundation for long-term sustainability. In a more complete research of this research, this objective could be explained with comparative case study across different countries and validations with later datasets. Okay, the next call is theoretical background and theoretical foundation of our work is within on three key pillars. Number one, lean manufacturing, which focus on eliminating wasting, improving flow, and increasing productivity is the highly effective for such operational improvements. Number two, circular economy, which promotes resource reuse, recycling, and closing loop systems. Is the extended probably recycling and reduce depends on virgin resource. Number three, sustainability, which integrate environments and social responsibility in the industrial operationals, ensuring that growth does become and expand beyond the future generations. By marrying the purpose, we move from isolated initiative down to a holistic system where efficient resource regularity and sustainability indicators are considered simultaneously. This novelty is important because it helps management the viewer understand trade of for example reduction late time will also reducing water use. Okay, the methodology our methodology is based on toxic process, which consists of 7 systematic steps and defining the alternative and evaluation criteria, normalize that data to eliminate scale difference, apply wave of the criteria in definition the positive and negative ideal solutions, calculating the distance of each alternative from the ideal solutions, putting the relief clones to the ideal solutions, ranking the alternative from best to worst. For this study, we can construct decision matrix with 9 criteria. These were divided in the 3 categories: lean indicator, lead time reduction, improve the OEE or indicator, and the effects reductions. Circular in the indicator percent the recycled material use or production waste, closed loop, life cycle maturing. Sustainability indicator reduce CO2 emission reductions whether you use usage reduction and energy efficiency improvements. This methodology allows translate quality goals into measurable comparisons is instead of discussions with restaurants sounds better. We were able the provide numerical ranking supported by data in the full version of this study. We plan to show that the late mathematical derivation provide a justification for the use of the equal weights and conduct and sensibility analysis the test the stability of the rankings. The last line that is no line number 5. The conclusion is the Topsy model products a cleaner ranking of alternative is 9 criteria and TPM plus number 1 is lead time reduction, number 2 aware improvements, number 3 defect rate reduction, recycled materials, waste reuse in the production, close loops, life cycle manufacturing, emission reduce and reduction the CO2 for water emissions reductions and energy efficient improvements. Okay, the last slide is our conclusion. To conclude, let me emphasize 3 key measures for our study. Lean practice are the immediate conditions to like PPM and SMED and BCM and Canva and deliver rapid improvements in the efficiency and productivity, which are crucial for competitive. Circular and digital practice are structured reinforcements. They might take longer to show results, but are essential for achievements, environment goals, and compliance with international sustainability standards. Integration is the novelty or framework demonstrated that lean circularity and sustainability should not be treated as a separate initiative, but a converged system for advanced planning. In the sense, the contributions of our research is both practical and academic. If give management structured tools, the prioritize strategy will also opening with new pathway for research and integrated planning. In the extended versions, we will present a validation plan, discussion, managerial implication, and exploring opportunities to replicate framework in our manufacturing industries such automotive, electronics, and food processing. Thank you. Hello.
Yes, good afternoon, Sir Kevin. I have a question. So in implementing lean initiatives with embedded circularity, what specific metrics or indicators would you recommend for monitoring long-term sustainability performance beyond initial efficiency gains?
Oh, okay. Sorry. The metrics uh, for long term sustainability performance sustainability, for long-term sustainability performance, I will recommend indicator that will measure productivity and focus on environment and social impacts. For example, the carbon footprint reductions, water usage efficiency percentage and renewable energy using in the productions, the material security, waste diversion rates, and supplier sustainability compliance.
So thank you.
Okay.
Thank you for the presentation. We'll be
Okay.
moving on to the next presenter. We have Sankama Sarawat with the paper titled AI-driven stakeholder-centered curriculum design for global media innovation, a case study from Thailand.
Sorry. Can you see my slide presentation?
Yes, you can start.
Okay, thank you. Sorry, just a moment. Hi, everyone. Today, I'm really pleased to present the research titled AI-driven stakeholder-centered curriculum design for global media innovation, a case study from Thailand. I'm from Silapakon University, Bangkok. As part of this session on the study how stakeholder collaboration can shape AI integrated media education. As we have seen, the global media landscape is undergoing significant transformation driven by AI, increasing demand for cross-cultural content. Thailand's media industry is globally recognized for its strengths and in post-production, visual effects, and cultural storytelling. But challenges like IP management, digital monetization, and cross-border distribution remain. So, the objective of this study to look at how the global media landscape is changing, especially with the rise of AI. What we have found on is how evolving stakeholders like educators, media professionals, students, and policymakers can help shape a more relevant AI integrated curriculum in global media education. The research draw on a curriculum initiative from a master's program in Thailand, where tools like AI, media production tech, and entrepreneurial thinking were combined in practice. We gather insights from over 50 stakeholders and use thematic analysis to identify key priorities. So let me show you the finding from my review literature. The first approach focusing on AI integrated curriculum design. The second one is stakeholder-driven curriculum innovation design. And the last one is AI and social innovation through entrepreneurial learning. Let me start with the first one. Once the most influential framework for embedding technology within education is TPACK, or Technological Pedagogical Content Knowledge Model. And framework assert the effective educational technology use arise from the intersection of content, pedagogy, and technology. In the context of AI, TPACK supports the view that AI tools should not be treated merely as standalone technologies, but as an element that can reshape how we think about and share knowledge. So to address the importance of this framework, so it's very important to think thoughtfully about engagement with ethical questions and critical thinking and also technological advance. For example, I put the theorist Biesta and also Falcon, two of them lay down foundation for multidimensional competency, including technical insight and critical awareness and creative application. So the second framework, we reviewing the entrepreneurship, which is the notion of social innovation, broadly defined as collaborative efforts to address complicated social problems, has been extensively shaped, but the importance of cross-sector collaboration, user-informed design, and the reframing of values and institutional legitimacy as a central to innovation. So, when engagement directly with AI, the framework invites reinterpretation in light of AI-mediated education. From this perspective, educators may see AI not merely as a tool for enhancing efficiency, but as a potential medium for advancing inclusion, democratic representations, and public value. So, our research method. The study adopts a qualitative case study approach grounded in principles of design-based research to examine how stakeholder engagement can meaningfully inform the development of an AI-integrated curriculum for media and innovation education. So we emphasize on participatory collaboration and context-based understanding. So population and sample. The population comprises individuals and organizations active involved in Thailand's media, education, and innovation sectors. 6 stakeholders groups were purposefully selected using purposive sampling based on their relevance to curricular reform and their embeddedness within the media innovation landscape. The first group is media industry entrepreneurs. For example, film producers, concert organizers, and streaming executives. The second group is content creators. For example, content directors, screenwriters for Netflix, and creative directors for ADM, world-class concert. The third is government officials and cultural policy makers. The fourth is academics and scholars in technology and communication. The fifth was prospective students and alumni. And the last one is full-time faculty members in media and communication programs. In total, insights were gathered from over 50 participants between April and June 2025. So, data were generated through a combination semi-structured interviews, focus group discussions, and written feedback form. And then we use data analysis, thematic content analysis was employed to identify patterns and insights across stakeholder response. The analytic procedure follow Bruin and Craig's 6-phase model, familiarization, initial coding, theme generation, theme review, defining and naming themes, and final write-up. Coding was carried out manually and supported by memo writing, which allowed the research team to reflect on the interpretation throughout the process. Emerging themes were then compared with key theoretical ideas from the literature review, including AI literacy, social innovation, and entrepreneurial learning to ensure conceptual consistency. So the result thematic analysis of the data gathered from 6 stakeholders group identify 3 central themes that help guide the development of an AI integrated curriculum for global media education in Thailand. These were integrating AI as a mean to develop both technological fluency and ethical awareness. The second is aligning graduate attributes with the demands of the global media environment. And the last one, positioning the curriculums as a platform for social innovation and entrepreneurship. This is an example of the result. Many stakeholders highlight that AI should be regarded as an optional component and be something meaningfully integrated throughout both creative workflows and strategic decision-making. Professionals working in film, animation, and streaming industries shared specific examples of how AI tools are now embedded in practices such as virtual production, subtitling, quality assurance, and predictive analysis. They are also suggesting that graduates will increasingly need to engage with these tools in hands-on applied context. Equally prominent was the view that AI literacy must extend beyond functionality to incorporate ethical listening, thoughtful prompt construction, and data literacy. Okay, so you can see the result about critical engagement with AI. And then the framework alignment. Framing curriculum as a catalyst for social innovation and entrepreneurship. Many participants, especially content creators, expect a desire to see curriculum function as a space for experimentation and social problem solving, rather than as narrowly defined training pipelines. Government stakeholders echo this view by highlighting the importance of fostering entrepreneurial mindset that are both ethically grounded and regionally inclusive. This aligns well with characterization of social innovation. So the finding highlight what we interpret as a shared recognition among stakeholders, that the 3 emergent themes are not mere design preferences, but structural imperatives for meaningful and enduring curriculum reform. So the study has examined how multi-stakeholder engagement can inform the development of an AI integrated curriculum in the field of global media education through qualitative input from over 50 participants across 6 stakeholder groups. 3 interrelated curriculum priorities were identified. The first one, positioning AI as more than a technical skill by embedding it into critical and creative practice. So as you can see, the summary of key themes or illustrative stakeholder quotes. The second, aligning graduate capabilities with the evolving demands of global media industry. And the last one, reimagining the curriculum as a space for inclusive innovation and entrepreneurship.
Dear author, I'd just like to remind you of the time limit.
Yeah, okay, thank you. So in this study, we just proposed a stakeholder-centered AI curriculum framework comprising 4 core elements: AI literate practice, transdisciplinary integration, curriculum as innovation lab, stakeholders partnership governance. Thank you. In figure 1, the framework enable institutions to align curricular strategy with both global innovation trends and local cultural capacities. Thank you very much.
I have a question. How does your proposed AI integrated curriculum model ensure adaptability across diverse cultural and institutional contexts, especially in regions with limited access to, say, advanced media technologies or AI infrastructures?
That's very tough, you know. Actually, we admitted that our research mainly highlight 3 core priorities to shape the curriculum design. Actually, we mainly focus on in Bangkok universities. I admitted that it's quite difficult for the moment, which is we have to study more on this. Thank you for your suggestion.
Thank you.
Yeah.
Thank you for the presentation. Moving on to our next presenter, we have Chetna NS with the paper titled An Innovative Hybrid Approach to Image Steganography, Combining Nonlinear Cost Functions with Structured Matrix Operations for Enhanced Security.
Hello. Ma'am, am I
Do
audible?
we have Chetna present in the session?
Yeah, ma'am, this is Chetna.
Okay. You can
Yeah.
start sharing your screen and present the
Yeah.
paper.
Ma'am, is this screen visible?
Not yet. Yes. Yes, it's visible now.
Okay. Okay, okay, ma'am. Yeah. Okay, my topic is an innovative hybrid approach to steganography. Here, I'm going to combine the technology of nonlinear function with the secured matrix approach. And here, nonlinear cost function with the structured matrix operation for enhanced security. So here we are enhancing the security of steganographic method, and in this I'm going to give a presentation on with introduction, constraints of linear cost functions, because we have been having many functions like constraints with the linear cost functions, and we're going to have a so that we're going to have a benefit with the nonlinear functions, so that we're going to use that method. And here matrix based steganographic method is also combined with the nonlinear cost function, so that the method will be enhanced, that is steganographic method is enhanced here. And with this we have done the quality analysis, that is visual quality assessment is done for many images, and embedding capacity analysis also done, and a steganographic resilience resistance evaluation is also done. Detection accuracy will be analyzed, and I'm going to present you the final remarks of the paper. So the introduction, I'm going to tell you like the steganographic method means will be it's very important to secure the message or any information, because with the ubiquitous use of internet and digital media technology increases the security issues, so that the primary concern of every individual and organization is the security of sensitive information. So users, they're going to use the technology devices such as mobiles and computers. They're going to connect with them, and they'll be having money. They're going to be used with the internet, so that there may be chances of getting less security for the information. So that addressing issues will be there for the issue of security to the internet users while exchanging the data is the most important thing that we need to concentrate. So that here for the data protection, it is essential to build a set of algorithms for shielding the data from unwanted access. So other people or the unwanted access can be avoided with the technologies like cryptography and steganography, and we can do the combination of these two for the information, so that we can safeguard the message. The landscaping of digital steganography has evolved into a cornerstone technology for maintaining secure communication in our interconnected digital world, where we are safeguarding the privacy and are going to protect the information. So sensitive information can be protected by critical priorities. The digital steganography has undergone remarkable transformation since the introduction of fundamental LSB technique. Substitution techniques help there. So every method primarily focused on the maximizing the data capacity with the limited consideration of security against the statistical examinations. So we'll be having many constraints regarding linear cast functions. The traditional linear functions, they're going to be used with the basic assumption that total distortion from steganographic embedding can be represented as a simple sum of individual pixels. So whatever the changes are there, they'll be just summing up, and then while computationally efficient and mathematically manageable, this linear approach fails to capture the complex interdependencies expecting the between the neighboring pixels in natural photographs. So we'll be introduced with the independence of assumption leads to suboptimal embedding choices that may create detectable statistical anomalies. So here we are going to combine two technologies here, that is matrix-based steganography method and a nonlinear cost function. So here the first we're going to take the image and we're going to do a triangular matrix. We're going to consider the binary triangular matrix, and we have done a steganography randomizing the benefits with the computational efficiency. That is we have this is one innovative approach that we have tried with this. So that was another one is the nonlinear cost function, or this proposed nonlinear cost function. It represents a fundamental departure from the traditional linear distortion models. The traditional foundation builds upon the observation that so this is the visual quality assessment for different steganographic methods that we have taken. You go wow, and here many images are taken here. Lena, baboon, and pepper, and Barbara, and these are taken, and we have analyzed with the visual quality. And with this, the proposed method will be having more PSNR value, and will be having a good assessment with the structural analysis. So here, another one is embedding capacity we have done here. So for different PSNR values, we're going to have for different methods, we're going to have a different PSNR values. With the proposed technology, there'll be an improvement in this embedding capacity. That means that whatever the data that we're going to embed on the image will be having better when compared to the traditional methods. So the other one is steganographic analysis response evaluation. So here we have done.
I guess there is some network issue from your end. Chetna, we cannot hear you. Okay, so there have been some network issues from her end. So for now, we'll be moving forward to the next presenter. We have Sir Sergi with the paper titled Big Data Driven Correction Coefficients in the 360-degree Feedback Method.
Hello.
Hello, I'm Sergey Sechov. This our paper with Ursula Podosinin and Yuri Mikheev. So I tried to share the page now. Okay. So our research is on 30-degree feedback method. So the issue of the method, it provide the survey inside organization on when people using some survey evaluate the competence of other workers, and by mathematical processing of this data, we can figure out how the person is sufficient for this job, what is evaluation of others, and generally to understand how competent the person for the position is. In this this feedback method was proposed initially from 20th century in the 80s after the Second World War, and was developed by the Ward from Britain, who introduced the name 30 degrees. So it means that all the people communicating with this person can evaluate him and give feedback. So here we see the categories that used self-assessment. So the person assess himself, how he suitable for his position, supervisor, peer feedback, and subordinate feedback, and clients and other experts. And the main problem of the method that the role of evaluee who gives assessment influence the result of the assessment. And our research tried to mitigate these biases, so to improve somehow the estimation of the position, the estimation of the performance. In general, literature considers that influence of the relationships between the person and the other person who evaluates him can influence up to 30% of this evaluation. General feedback gives leadership, communication, collaboration, accountability, innovation, and customer focus. These are general categories that are embedded in the survey, and the survey provided by a psychologist or manager, so they focus on these categories. So what was included as main processes in our research? These are data collection, of course, and so it was performed around 15,000 different researches, small personal researches on different companies inside the Russian Federation. And so the questionnaire used, as I mentioned here, around 1 to 5 or 1 to 7 scale after processing. So it was scaled. We use so data collection, data aggregation by category, and analysis, then report and feedback. So feedback is one of most important parts when calculated data given back to employee, and in collective they can either personally or collectively people can discuss a result and correct themselves. And before discussing, the mathematical correction can be made. So what we concentrated on, just like this, I think, we concentrated on influence of, again, on the influence of respondents' role, the impact of interpersonal relationships between the respondent and recipients, and effect of evaluative style. So evaluative style is sort of hidden characteristics, not in some researches it was considered with additional questionnaire. So some people have tendency to overestimate people with whom they correspond, some underestimate, and that this characteristic is influencing all the lifestyle of person, and it's one of the most difficult to catch. So again, data collection, data aggregation, analysis, report generation. As I mentioned, it was made in the Russian Federation and about 15,000 participants, so quite big research. So here demonstrated what we use how seen generally the scale which we consider it. So here three the question. Frequency. And the process how we evaluate it. So 4 categories and how they affect. So external category from outside team, subordinates, supervisor, and colleagues. So this. And after research, we figure out 5 factors mathematically. So it was quite a complex combined Python program and a set of methods. The main, of course, is evaluative competence. As I mentioned, the second factor is role. So the attitude and the relationships between 2 persons who evaluate and who is evaluated. So the third factor, as I mentioned, respondent style, and these are very difficult to figure out. So formal relationships and status. Status affects too. So subordinates are evaluated generally less, and that is very important. And so the chiefs or head of group evaluated with bigger rate. And that was one of the main result of research. So we have, after using this method, we have to make
For the introduction, this is a 9 minutes gentle reminder.
Say me please again.
This is a time limit reminder for the 9 minutes.
Okay, yeah.
Yeah.
Okay. So here are some math that we use. So it's possibly here not time to describe, but we use 5 factors as I mentioned. And there is a formula using covariance for contribution of each of the factor. We saw influence of the factors here. So competence is most influenced definitely, but the second is status. So the higher the position, the higher the rate. And when we consider the result, we have to decrease the real, in this method, we have to decrease the real scores of person if he has higher status, and increase if he has lower status. So the 10% are from the style, and 6% are from the relationships. So here the main results, role-based differences. Subordinates tend to give higher scores to their chiefs. Supervisors often gave more critical to their subordinates. Relationships. So if there are friendly relationships, the scores are higher. If persons are in conflict, they give less rate. And the third, evaluative style. So it's personal or style. Either the person is critical or like exaggerating everything, very optimistic, giving high rate. And the recommendation for employee and for everyone who concerning this method. So we count for employee status. So decrease for the chiefs, for leaders, and increase for subordinate. Individually competences. very important look in details, and the third is just a bit repeated, and qualitative feedback, it's very important. Okay, so I think that's all on 30-degree feedback method. Okay.
Yes, here's your question. What are the ethical considerations in applying such algorithmic corrections to human evaluations, and how does your framework ensures transparency and trust among stakeholders using the 360-degree feedback system?
The trust. Generally, the trust wasn't included. Ethical consideration. It was provided in big companies, and they are generally harsh to the employee and to everyone. So the general purpose was to increase productivity of companies. So it was like State Bank and others. And providers of this research, so psychologists who provided, they definitely try to follow ethical considerations and some ethical code. But generally speaking, of course, big companies are not ethical generally. They're mostly looking for productivity. And this was for productivity. What is ethical here is that it can, as mentioned here, if some person is subordinate, the research supports him, so saying that if it's not in high position, on a low position, do not rate him like harshly, violently, so people look from him from top to down, and so possibly he's more valuable than on this than formal research. So it gives some addition and improvement in rates for subordinate. And I think these main ethical consideration. In big companies, there is a tendency to look on people from point of view of digits, and this research adds some human perspective on this.
All right, thank you. Thank you so much.
Okay, any question?
Okay, thank you for the presentation.
Okay, thank you.
Okay, so now we have Sheetal, who couldn't present previously. Ma'am Sheetal, are you ready with your presentation?
Yes, ma'am. Am I audible?
Yes, you're audible.
Yes, ma'am.
Share
I'll
your
share my screen. Yes, ma'am.
Okay.
Is screen is visible, ma'am?
Yes.
Yes. Yes. Hello. Good afternoon, everyone. My name is Sheetal Khapade, and my today's review research topic is a holistic review of deep learning method in speech emotion recognition. So these are the contents. Abstract, the field of study which analyzes the mood of a person from speech is called a speech emotion recognition. Classifying the emotions from speech, it's a difficult task for AI, and it's a multidisciplinary, machine learning and deep learning. Various methods are used of deep learning to analyze the emotions through speech. So our review discuss current research on this, having various methods of deep learning, like long short-term memory network, recurrent neural network, convolution neural network, and a hybrid method like CNN, BIL, STM, of for speech emotion recognition task. I have told you that it is nothing but the study of which analyzes the mood of a person from the speech is called the speech emotion recognition. And in research, we are researching and try to develop a model which is based on the deep learning with the using a transfer based attention and a graph convolution network to enhance the feature representation and able to classify the emotions very accurately and scalability for robust speech emotion recognition applications. So as we will take the signal of speech and then we analyze it and try to classify the mood of a person, and that emotions are of different type like happiness, anger, sadness, surprise, fear, and so on. For this, it's as it I told you that it's a review paper. We have done various research on whatever the previous work has done on this particular field. So one of the important paper recent that is 2024 paper we have studied. It's a capsule enhanced neural network, which innovative metrics for a robot speech emotion recognition. This paper they have worked using this technique, and they have tried to identify various types of mood with a more accuracy, but it also have a certain limitation. The model is as it is a combination of other multi-head attention and other modules, so it become little bit complex, and because of this complexity the performance is degraded. Another important paper we have studied is a hybrid CNN BIL-STM architecture. Here also they have tried using this method. They have tried to identify various emotions through speech and maintain the accuracy, but they got the average accuracy on public and private data sets. Other papers also we have studied speech emotion recognition using uh, GRU LSTM, which they are getting the precision of 90 and 62, but again they have certain limitation. Generalization means all the data sets are not accurately they are identifying with this particular method. Then we have another deep learning method, speech emotion recognition using multiple acoustic feature, which recognition rate is 97, but they have again accuracy, but complexity computation efficiency is less, and they have a complexity in their performance. The model become complex, and which degrades the performance. So these are the various papers we have studied, and we have find out some limitations and drawbacks, that is the research gap, and we are trying to overcome those research gaps. So proposed model methodology, we have this is the architecture of our proposed methodology. We'll take the data set, we do the pre-processing on the data set, means cleaning of data set we'll do. After that we'll try to do the feature extraction. We select the features. In this we are using multi-head attentions for getting a better or enhanced feature extraction. Then we applied the hybrid model which is based on the deep learning like CNN by LSTM CENN. This model will train and try to optimize this model. We'll evaluate the performance of the model. We'll parameter tuning will do, and we'll try to get the final model for which actually able to give the more accuracy. And so whatever the results we'll get from this model, we'll try to analyze and we'll get the accuracy compared to the other previous methods. So this proposed work consists of these important stages: data collection, pre-processing, feature extraction and representation, deep learning, a model architecture that we will develop, and training of that model optimization will do, then evaluation validation, and whatever the we'll try to compare the results of our model with the previous models, and try to deploy this in the real world applications. So the expected outcome is we as we are proposing this model just to enhance the accuracy and try to identify much more emotions, and give a generalization that whatever the data set will be there, we'll try to get a accurate results just to identify the emotions accurately, efficiently from this model. And the conclusion is this only, that by integrating this multimodal fusion, that is audio and some textual with the graph convolution network, the model will enhance the feature extraction and the representation, and we'll try to give a generalized model and try a classification accuracy of emotions also we try to achieve. Future scope, future scope is as this model will more used for the real time applications, and this model will be adaptable for different languages, so that it can be used with the other languages also. Multimodal inputs, text, features, text and speech will try to implement and implement it in a real world applications. And this whole, that is complex part, this also this future scope will be, this model can also be used for the other complex pattern recognition tasks, such as medical diagnosis and behavioral analysis. This model can be helpful in the future scope, future we can use it for this purpose. So these are the references we have studied. This is all what I have presented in my in paper. Thank you so much. Thank you, everyone.
All right. So thank you. So here's my question.
Yes, sir.
Given the persistent challenge of imbalanced data sets, say in SER, what strategies do you recommend for augmenting training data to improve model generalizability across diverse emotional expressions?
Uh, yes, sir. Actually, we are we try to develop that model, hybrid model, which consists of DL techniques, that is deep learning techniques, CNN, BiLSTM, and CENN, just to provide a generalization for any type of data set. This model will work, and we'll try to get a accurate, enhance the accuracy in classification, classifying the various emotions through speech.
Right. Thank you.
Yes, sir.
Okay, so your aim is to improve the accuracy, right?
Yes, sir.
But I couldn't find any slide where you have mentioned that how much of the accuracy got improved.
Sir, actually, this is a review paper, so our work is still going on. So we are just started the implementation, and we are definitely trying to increase the accuracy, sir.
Oh, so you still haven't increased.
Yes, sir. It's working is going on, sir.
Okay, thank you.
Yes, sir. Thank you.
Thank you for the presentation.
Thank you, ma'am.
Moving on in the session to our next presenter, we have Zaid bin Munir Atib with the paper titled Comprehensive Assessment of Deep and Traditional ML Approaches for Multi-Class Skin Disease Recognition. So Zaid, are you present in the session?
Hello, can you hear me?
Yes, we can hear you.
Hello?
Yes, you're audible and your screen is also visible. You can start the presentation.
Yeah. Hello, everyone. Thanks for being here. Today, I'm sharing a comprehensive assessment of deep and traditional machine learning approaches for multi-class screen disease recognition. So we built and comprehend models to recognize 5 common skin diseases from photos, and our custom CNN reached about 99% accuracy. So this is the table of content. Here the plan is the global challenge, our AI solutions, the dataset, method, results by disease performance, and comparison with other research, real world impact, and future works. So we're going to talk about the global skin disease challenges. The skin diseases are very common. Roughly 1/3 of people worldwide are affected by it, but many people can't see a specialist. Over 1 billion patients lack access. This causes delays and suffering. Our goal is to support early detection so patients get help faster. Uh, the AI, especially convolutional neural network, can learn visual patterns from images and classify diseases quickly. With the phone camera and a trained model, we can screen patients and guide them to care sooner, even where dermatologists are scarce. So the target condition and data set are we focus on data sets acne, con- contact dermatologies and Neil fungus, scabies, artesia, and we built a balanced data set of 8,900 clinical images, 1,780 per class, and we resized and normalized the images and then used augmentation. It makes the model more robust to real life conditions. And next one, we're going to talk about our custom CNN architecture and methodology. Our custom CNN has 5 convolutional blocks with filters 32, 64, 128, 256, and 512. And it uses 3 into 3 kernels, each follows by max pooling and dropout of 0.25 to reduce overfitting. And we flatten features, pass them to dense layer with 1500 units ReLU, and then use a softmax to predict the 5 classes. We split the data to 90% to development and 10% to training. The inside development we use 80% of for data to train and 20% for validation. We report accuracy, precision, recall, and F1 scores. So this is the exponential expectational performance results. Our
Zach,
custom,
I'm sorry to interrupt, but are you changing slides?
yeah, I am.
It is not being reflected at my screen. Is it the same with others or is it only
Yes,
mine?
it's the same.
Yeah. So if you can
Uh,
stop sharing and reshare and then
yeah,
continue.
yeah, yeah, yeah. I'm. Hold on. Can you say it now?
Yeah, I'm at exceptional performance results.
Should I start from beginning or just
No, no,
continue?
you can continue from here.
Okay, so here's our exceptional performance results. Our custom CNN achieved 99% overall accuracy. Two strong baselines of ResNet 50 and BTC16 reached about 98% and 97%, but our model still outperformed them and performed best. The accuracy loss curves and confusion metrics show stable training and few mistakes only. So we're going to talk about the details performance analysis by disease types. By class, the acne precision was 1, like 100%, and recall was 100%. The contact dermatitis precision was 0.99 and recall was 1. And Neil fungus, the precision was 1 and recall was 9.93. You can see by that. And scabies has like almost perfect. The recall was 1 and the F1 score was 0.99. And this shows the high consistency reliability across diseases. And next, we're going to talk about the comparative analysis with existing research. The Better et al. Uses actually two-stage exceptions pipelines with 95% accuracy, and Mina et al. Uses a lightweight KNN method with 97.53% accuracy. But our custom CNN with 8,900 images uh, reaches accuracy of 99%. So we deliver high accuracy on a balanced and larger data set and with efficient deployment potential. So the clinical impact real world application, like what does this mean in practice? With 99% accuracy and strong generalization, our model is suitable for teledermatology and primary care triad. A web-based tool can provide quick first screening, speed of referrals, and reduce burden on specialists, especially on resource-limited settings. So, what are gonna be the future directions and research opportunities? So, next steps can be like fairness and robustness, optimize across the different skin tones like lightning and devices, and multimodal inputs can be like it can combine the symptoms and history with images, and dataset expansion and external validation might be resulting a better outcome, like it can cover more diseases and test at new sites to prove generalization. So thank you everyone, that's all from me. If you want to ask any question, feel free to ask. Hello.
Yes. Here's your question. Considering the model's superior performance, like over traditional ML and pre-trained deep networks, what are the possible implications for, say, clinical integrations, particularly in terms of interpretability or regulatory approval, or say, physicians' trust?
Okay, so can you repeat the question again?
Okay. Considering the model's superiority,
Yeah,
performance over traditional ML
yeah.
and pre-trained deep networks, what do you think are the possible implications for clinical integration?
Like it can actually provide more accuracy to the five diseases we mentioned. So the previous models actually they also had better accuracy, like high accuracy, but ours was really good. So with the extended data set, we actually almost gave the at least almost perfect result. That's we can say that.
All right, thank you.
Okay.
Thank you for the presentation. Now moving on to the next presenter for this session, we have Amrita Khanaj with the paper titled Enhancing Open Source Software Security Through Intelligent Monitoring of Community Sourced Code Snippets. Amrita, are you ready with your presentation?
Hey, hi everyone.
Okay.
Yeah, I'm ready. I will share my screen.
Sure.
Yeah, is this visible?
Yes, it's visible.
Okay. So yeah, good afternoon, everyone. So this our work is on the. So this is our work title. So enhancing open source software security through intelligent monitoring of community source code snippets. So this main work is like as a developers, like we all know that Stack Overflow is a go-to source. So millions of developers are like copying snippets directly from it into their projects. So it saves the time, but like there is a hidden risk. Many of these snippets like become outdated or insecure over time. So unfortunately, when Stack Overflow code evolves with fixes and improvements, so developers like rarely update the copied code in their own projects. So this gap exposes the open source systems to serious vulnerabilities. So our work introduces like an intelligent monitoring system that bridges this gap. So it automatically detects the reuse Stack Overflow snippets in the GitHub projects and tracks the changes and notifies the developers whenever their code is outdated or vulnerable. So going forward, when you check the background, so why we consider this system is prior studies shows that there is a large portion of Stack Overflow code snippets which contains the vulnerabilities. Thing is improper API uses are there, weak cryptographic functions or insecure practices were there. So in contrast, third-party libraries have structured ways to track the updates, such as a CV database, but those snippets don't have any such system. That means while Stack Overflow snippets frequently evolve with the security fixes, open source projects continue with the older run and the unsafe versions. So this independent evolution between the snippet and the project leads to the lag in the security. So this existing research has identified the insecure snippets, but there was no automated system that continuously connects the Stack Overflow and GitHub to keep the developers informed. So this gap is exactly what we address here. So moving forward with the methodology, our system works in the three main stages. So first, we perform code similarity detection. So using the abstract syntax tree analysis and a cosine similarity. And the system identifies whether a snippet in a GitHub repository came from Stack Overflow or not. So second is we perform the security patch analysis, and here we use the code QL to check if the updated snippets fix the vulnerabilities or not. So we also use the NLP here on commit messages to classify whether an update is security related. And then finally, we have the developer notification and monitoring. So this system automatically sends alerts through the email or GitHub issues. So currently now we just implemented this email system, and GitHub issues we are working. So in addition, an interactive dashboards provides a visual history of the snippet revisions. Then moving forward for the result and evaluation, so this is flow chart. So coming to the result, so we achieved the score 91.6%, which shows strong accuracy in detecting the outdated snippets. And in our evaluation, nearly 70% of potential vulnerabilities were prevented by these alerts, and developer feedback was also positive. 85% developers who received notification agreed that this system helped them manage security updates more effectively. And these results prove that the treating copied snippets as a dynamic dependencies, just like libraries, can significantly improve open source security. Into the conclusion, many of the copied Stack Overflow snippets remain outdated, creating the hidden vulnerabilities. So continuous monitoring and intelligent detection can reduce this risk dramatically. And by automatically linking Stack Overflow with the GitHub, we help developers stay aware of the updates and the security patches. So looking forward, we are planning to extend this work by integrating with the IDs so that developers can get real-time alerts as they write the code, and also by connecting not just to the Stack Overflow but also the CV database and the security advisories. And also we can try by advancing our machine learning models to better classify these vulnerabilities and even predict these potential risks. So our future vision is like to build a future where community knowledge and the security tools work like side by side, so developers can innovate faster without compromising the safety. So like this is overall our work. So we believe like this work is a step toward making open source software more secure. So yeah. So thank you for attending this one.
All right. Thank you very much for that very innovative study. So the question is, considering the dynamic nature of open source projects, how scalable is your framework for real-time monitoring across thousands of repositories?
Oh, okay, so like currently we have implemented a small system for this one. So like few of the repositories we tried. So but if we are considering the large repositories, then like we will try forward to use the CV database. So like there we will have the large number of repositories. Then that work is like we are still doing. So we will try that one as well. So this is our the future scope.
All right. Thank you. That would be all.
Yeah, thank you.
Moving on to the next presenter for this session. We have Sadia Siddiqa with the paper titled Grading, Packaging and Real-Time Transport Management System of Agriculture.
Am I audible?
Yes.
Okay. Hello everyone. I'm Sadia Siddiqa. Now I'm presenting our topics or tasks or like this is grading, packaging and real-time transmission transport management system of agriculture. In first, we go for our outline of the presentation. Here we can see that abstract introduction, literature review, problem statement, methodology, proposed solution, result and discussion, conclusion and references. And we go for our next part is abstract part. Abstract part, we can see that the study emphasized the improve of the grading, packaging, and the transporting agriculture products, especially perishable the items, and using the technologies like IoT system and the computer vision and the smart packaging and barcode to ensure the freshness and safety traceability. You can see that it's mainly a app-based system to automation of the product to supply chain. And in next slide, you can see that the introduction part. Here you can see that the proposed a smart technology is based up post-harvest system, integrating the computer vision of the grading, intelligence packaging with the sensors and the digital twins for the transport and the secure the database management to improve the freshness, safety, and the traceability. Here the process enhance the efficiency through the automated grading like ripeness, size, color, pathogens detection, quality verification, and spoilage monitoring, and the management system integration. And this system, we can identify the future direction of the, including the advanced image processing, features extraction, and the use of the blockchain and IoT system. Here you can see that the literature review. Here, in our literature review, we can different type of views like
technology advantage, we can see that the AI and ML and deep learning robotics, the RFID digital twins and intelligence packaging improve the grading, traceability, and the sustainable ability to post-harvest efficiency. And application basis, we can see that the non-invasive food, coffee, and the grading and the ripeness and the defect integration with the model. In the sustainability and the standardization, we can see that the compiles with the UI and globalization, it be usable for the material, the inspection, the training, enhance the food safety and the certification integrity, consumer trust. And we can face the different type of challenges in this literature review. Challenges are most highlighted that high cost and scalability issues and the challenge for risks for data security mission. Problem statement, in this paper we can select some problem statement like this system image is extracted the level of manual grading system, supply chain management, which is mainly inefficient, labor intensive, and the error prone. And in this figure, when we can see that the all the process is manually processing system, like in the crop is collecting by manually and manually harvesting, and post harvesting system all goes on the manual services and so on. In this methodology part, we can see that we mainly process this work to farm to the consumer system. Here we can see that this process is organized from the farmer to the consumer cycle, real-time tracking. And data model, from this data segmentation, we can mainly work with the schemization and the normalization form. For that, data will be more precise from and which make us for usable from and which make the more data security. Database normalization reduce the redundancy to improve the integrity with the tracking the shipment through the key fields. Here, in this case, when we create a database table, then we fix a primary key and then other is foreign key and so on. In proposed solution, here you can see that figure 4 and figure 5. In our proposed solution, we mainly try to that it's mainly IoT system or mainly app-based, more efficient system. Here, system interfaces. The proposed system provided the multiple interfaces, including the grading, packaging, and real-time transmission. But we are working with more features, like it's a 10, more than 10. In these cases, we created the features of which is map-based tracking, supply chain report, delivery management, graded product list, and the cost report, and the contact system and the feedback system as well. In mainly our focus areas, like among these, the map-based system tracking, the supply chain report to highlight the original, the real-time insight to the farmer to consumer system. In next session, we can see that resulting discussion part. Resulting discussion part, we mainly work our process, go through a process like RQ question, which is a researchable question. In this space issues, we can do not highlight that, but we can explain it. Our researchable question highlight our all the work process. Mainly in figure 7, we can see the output of the working process. In our research question for the 4th RQ question covered the grading, AI integration, and the packaging, blockchain, and the traceability. Optimize the post-harvest system management. Core modules, we can see that the quality management system, real-time supply chain, which is mainly highlight our work process, and house maintains and ensure the quality and traceability and storage system. And you can also see that our output, here we can process the data. In this table too, we can see that we can mainly compare our existing system and the others existing system, a comparison based working process. Like our system, we can create more than 10 or 11 features which is more efficient than others. So here we highlight the comparison table. This part you can see that the conclusion is ensure the product tracking. We mainly supply fresh and good product to the consumer. Data security issues is here. Reduce the spoilage, cost effective, and improving the customer trust, and combines the IoT and the packaging, smart packaging system, grading, packaging, and transport system issues. Future work, we can use more AI features extraction and the image processing system. Here's some references for we are used in our paper. And thank you, everyone. Is there any question? Hello?
Yes, ma'am. Here's your question. How does your proposed system ensures interoperability and scalability across different agricultural contexts, perhaps such as smallholder farms, large scales, and in regions where there is limited digital infrastructure?
Okay, it's fine. Thank you. Mainly our system is a more enhanceable system because we are creating more features to ensure the users to flexibility. Like we created more than 10 features, which is so increasable for our highlight our features and other system. When we compare than others apps, then we see that there have some comparison basis questions like they had some features had no existence, but we have. So there we create a comparison table that make us that our system is more enhanceable.
Right. Thank you. Thank you so much.
Okay, thank you.
Thank you for the presentation. Moving on to the next presenter. We have Costa Rica DB with the paper titled Intelligent Information System for Proactive Management of a Printing Enterprise.
Hello to everyone. Nice to meet you. Kostev Dmitro, not DB, maybe it's mistake. Just sending the contacts. So let me share the screen and I will start the presentation. Today I show how we can use the Flex Estimate system and intelligent estimation platform using AI specifically for the printing industry, and how we can make the quotes faster, more accurate, and easier to execute on the production level. By reducing of reliance on human factors and increasing the accuracy, the Flex Estimate system is aimed to revolutionize the way printing projects are evaluated and managed. About the technology, some words about the technology and why it matters. The printing companies today live under the constant pressure, shorter lead times, decreasing of margins, and frequent specification changes. While prepress and production are increasingly automated, order estimation often remains manual. Tables, expert judgment, and static tariffs that create delays, inconsistent in pricing, and plans that fall apart when the real machine load or material balance doesn't match the spreadsheets. Flex Estimate addresses this gap by turning estimation into a data-driven learning process integrated with your actual operations. What Flex Estimate is? It's a modular system that ingests order data, different type of specification, predict cost and lead time, proposes execution scenarios, and generate customer-ready quotes. It began from the IT project estimation and was re-engineered for print offsets digital finishing, so print shops can respond in minutes with transparent definition numbers and realistic schedules. Theoretical basis of the flex estimate presented on this slide. So we use regression methods, classification methods, and data mining, cluster method, and NLP for creation of different type of estimations. Let me explain how it works. Data acquisition and NLP. The system pulls order parameters from the CRM, ERP, and parses unstructured briefs using NLP. That means it recognizes quantities, format, subtractors, colors, finishing steps, and constraints without manual retyping. Also, a system provides the order understanding. Machine learning models classify job type and complexity, then select likely technological roles. Forecasting. Regression models are trained on historical jobs, estimated lead times and costs, factoring in machine calendars, setup changeovers, typical waste, and current workload. Optimization and scheduling. Graph-based shop optimization generates scenarios, minimum cost, minimum time, or balanced, while minimizing idle time and changeovers and respecting material constraints. Dynamic pricing and documentation. A pricing engine applies policy and market factors to produce the final price. The system then auto-generates the commercial offers and internal production plan. Here you can see how it works when we are using data pre-processing. Data is cleaned, normalized, and structured. Then analytics model, then statistical methods for machine learning algorithms analyze the prepared data, and document management model where we can create the different type of estimation and offers. Industry issues and development goals. It already was discussed, and the flex estimate helps us to create more specific and customization options for specific projects and customer needs, providing a detailed project understanding on each level, starting from management level and continue to the customer. If we are talking about the benefits of optimization, it's reduced valuation time and using of manual work up to 60–70%. It's increased the accuracy. It gives us cost optimization because time of managers cost a lot and the machine times cost even more. And it gives us opportunity to create the offers in a seconds and provide us transparent communication with a customer. So let's check the example on this slide. And as you can see, this example was calculated just for a seconds when we have only brief description about this booklet, or even we can analyze the preprint of this booklet and adding the desired parameters. So let's talk about the technological side of our project. We are using Python and TensorFlow for backend, React for frontend to create the web version of the software, PostgreSQL for database, and standard things for server like AWS, Docker, and of course we need to use the NLP models for analyzing of order texts. Here you can see the several screens, how it works, and how we can put the data of the project, and how we can see the final results. So what will be our next steps? It's the integration with ERP, with different type of ERP and CRM. It depends from different type of CRM which already in usage on print shops. Of course, very interesting to work with 3D printing or with a specific packaging because it's more difficult task for estimation in comparison with traditional offset methods. And we are trying to extend it for different types of printing like Flexo. Yes, so in any case, you need to add more languages because now it's working with English and Ukrainian language. Thanks for your attention, and I'm open for questions. Hello?
Yes, do we have any questions?
No questions from my side.
Okay. Thank you for the presentation.
Thank you very much. Thank
Yes.
you.
We'll be moving on to the next presenter. We have Zarif Wasif with the paper titled Rural Bangladesh Before COVID, Baseline Trends and District Forecasts from the Life in the Field program.
Hello.
Yes.
Good afternoon, everyone. I am Zarif Asif Bhuiya, graduate assistant at Independent University of Bangladesh. Today, I am presenting Rural Bangladesh Before COVID, Baseline 10 and District Forecast from the Live in Field program. We used 8 years of village survey to build a clear pre-COVID baseline and make short forecast for education, job, health. Our goal is simple, turn messy data into useful facts for direction. Contents. Here is today's plan: research overview, study coverage, method, education trend, employment recovery, health insights, cross-district comparison, key findings and policy idea, future direction. Research overview. Rural data in Bangladesh is often scarce and does not last long. That makes it hard to see real changes. We use the Live in Field program at IOB. Each year, students live in a village and collect the same type of data. This gives us a solid record from 2013 to 2020. From the record, we build a baseline and make simple district forecast. Think it is a template other can reuse and extend. Study coverage. We study 6 digits, Joshua, that is our main focus, Bogura, Mymensingh, Sylhet, Borishal, and Dinajpur. We looked at education, medication, or health service users, employment, marital history, and acquired and chronic illness. Joshua has the best and longest data, so we model it fully and use the other district for comparison. Methods. Step 1, clean and combine data. We fixed header lineup the same question across year and make our simple index for each sector by district and year. Step 2, forecast. We with 8 yearly point, we use a basic time series model ARIMA to project the next few year and show uncertainty bands. Step 3, compare districts. We put result on the same scale so district can compare fairly. Education trends. Education improved stability from 2013 to 2020. In the forecast, it levels off, so we expect holding the gain, not a big jump. By 2019 to 2020, Joshua is the upper group. Policy idea protect the gain with the student retention and second chances program. Employment recovery. Employment falls around 2013 to 2015, recovers in 2016 to 2018, and is strong again by 2019 to 2020. The forecast show a small steady rise, is to return to normal, not a boom. Policy idea support skill train and small business to keep it recovery going. health insights. Three quick points here. Medication use goes up, some year jump across in better. But we must watch informal skills. Actual illness stay low and stable. Chronic illness show rise. We need more prevention, scanning, and long-term follow-up. Cause district comparison. Looking at 2018 to 2020 on the ISBM scale, unprescribable medicines increased most in Borishal and Dinaspur. Joshua and Sylhet rose a bit. Bogura was mostly flat. Village doctor uses went down in Borishal and Dinaspur, but up in Joshua in Sylhet. Chronic care follow-up dips in 2019 to recover Dinaspur improved the most. These patterns show where is the focus, medicine sharpship, referral and basic quality and better from up to chronic patients. Key finding and policy ideas. Education keep the gain, focus on keeping student in school and offer secondary chances. Employment, turn recovery into stable work with training and micro enterprise support. Health, key access to medicine but oversee information selling, reduce over reliance on village doctor with better referral and quickly check. Threat, chronic care, follow up at top priority. Future direction, extend full forecasting to all cities districts as new data comes. Check for post-COVID breaks and try a stronger model that share information across districts. Add outside data, prices, rainfall health facilities, density program coverage, and weight the survey where needed. Build a public dashboard and test a small pilot project. Thank you, everyone. I am happy to take questions.
All right. Thank you. Very insightful study. So, given the observed trends in forecast based on your study, how do you think policymakers use your findings to design district-specific interventions, like especially in areas showing rising chronic morbidity or stagnating educational gains?
Okay, thank you. Basically, our goal is to identify where the means we have say 8 districts, so people are 8 districts are not equal. So our plan is to identify the problem, which districts are become low and which districts are up. So from this information, policymakers are making the policy to up the lower districts. Lower districts means lower income and lower health, lower problem districts.
All right. Thank you very much.
Thank you.
Thank you for the presentation. And with that, we have completed all our presentations for this session. I sincerely thank all the authors for their presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, we thank you for your support during this 4th version. And all the previous 3 versions of the conference, we'll be happy to have you in the 5th version in 2026. All the presenters would be receiving their digital certificates within 2 working days, and the publication will be live within 7 to 8 months. So kindly cooperate with the team of ISBM 2025. I'd also like to thank our session chairs for chairing the session. Here is a token of appreciation on behalf of the team of ISBM, Global Knowledge Research Foundation, and partners. Professor Anne Julie D. Rosal and Professor Kaushal Shah. Thank you for your valuable presence.
Thank you. Thank you very much.
Thank you.
Now, just at the end, I request you all to please turn on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. See you all soon. Take care.
Thank you. Thank you very much.